So now let's take a look at the math of our confidence interval table at any given percentage gamma percent. So here you'll see our descriptive statistics. Those just represent your number of treatments in each group, the mean of that group, and then the standard deviation. Okay, so standard error, we're going to use the mean squared error of our ANOVA table, so our one-way ANOVA. And if you remember, that is just the sum squared deviation of each value in a group subtracted from that group's mean over the total number of measurements in the study minus the number of groups. And then, so if you run, and we'll do this later, we'll calculate this all, that mean squared over error is going to be mean squared over error over this number of measurements in group I, so that's this n value here. And so that one's pretty easy. Again, I would just like to say this is the SS error over DF error, so that's the SS error, sum squared error, and that is the degrees of freedom for our error. We will use the QE ANOVA one-way to calculate that for us. Okay, only other thing we have left are confidence intervals. So this is at any given percent, and I'll show you how we kind of put that in there. Okay, so pretty simple. It's just the mean of that group plus or minus t crit times our standard error, which we already calculated previously. So standard error of that group. Now, in the example that we're going to do, they all have the same, it's a balanced ANOVA, so they all have the same number of measurements. So our standard error is going to be the same, but that's not always going to be the case. So each one does have an individual standard error. It's just if all of the treatment groups are balanced and have the same number of samples, they will be the same standard error. So again, not always, but in this case, our confidence intervals are going to have the same width. Okay, but how do we get that t critical? And this is where that gamma percentage comes in. So if you take that percentage and write it as a decimal, so like let's say we want a 95% confidence interval, we would then use the value of 0.95, and then we take 1 minus gamma, and we input that into the t.inverse function in Excel as our probability, and then our degrees of freedom is our error degrees of freedom, which if you remember is n total minus n groups. Again, we are going to use the QE one-way ANOVA to calculate that for us. And that's it. That's the math. Realistically, we're only calculating that standard error and the confidence intervals. That's the only new stuff. The number, mean, standard deviation, that is stuff we're used to. So why don't we go ahead and take a look at this in Excel.